Okay, group, we are on the challenge lesson extra, practice here, and we are actually doing some linear regression on Desmos. So I'm going to actually use my phone for this when we need to use Desmos. If you're on a computer, great, that's amazing. It's not easy for me to do both here with my camera, so I'm just going to use my phone. And you can also use your phone. There's a Desmos app if you want to do that. I just have it pulled up on Safari here on my phone. So, all right, let's get started. A food scientist wants to understand how much sugar children like in their desserts. He sets up a study where children taste cups of vanilla pudding with varying sweetness and rate each cup on a scale of 1 to 10, where 10 is excellent. For each tasting, the food scientist writes down the grams of sugar in the pudding cup, X, as well as the rating, Y. So if we look at our X values here, okay, that's our grams of sugar. So if we want a window, this is kind of like the domain-ish, except for we're going to expand it a little bit. We don't want to go from 16 to 30 because that would be really, really tight. We're just going to go from 10 to 50. So if I go here to Desmos, if you pull up in the right-hand corner that wrench, you can change your x-axis. So mine's going to be from 10 to 50. Okay, and then my y-axis here goes from 1 to 10. So I'm just going to go from 0 to, like, you could go to 15, you could go to 20, whatever you want to do. I'm going to go from 0 to 20. I just like to be able to see everything that's going on, and we can always zoom out if we need to. Okay, so once we've done that, you can hit that wrench again and it will go away for you. Okay, let's calculate our equation. The first thing we have to do is put a table in here. So you're going to do, we're going to add a table. Okay, so our x value is 16. Okay, always double check your data. Make sure that your table is accurate. Okay, it looks good. Okay, so we put our table into one line. On the second line, you're going to type in this guy right here. So we'll do Y1. So Y, and then if you press this ABC button, it'll actually give you this A and then subscript of B, and that'll allow us to do Y subscript 1. So Y1. Okay, I'm going to come out of that. And then this little curly, I think that's also, if we press A, B, yep, right here. So put that in. It's also on your keyboard by the apostrophe, if you're on a computer. Okay, and then our slope M, X sub 1, plus B. If this is not perfectly accurate, then this will not pop up. So you want to make sure that this is accurate. Okay, you can't just do like Y1 or X1. You have to make sure that this has that subscript in there. Okay, so our equation, if we look at a Y equals mx plus b equation, all we're doing is filling everything in. So we have Y equals, our M is 0.45. Says round to the nearest 2 decimal places, so I had to round up there, X, and then our B value is this negative 6.18, and so that's our y-intercept. So there's our equation for our line of best fit. Okay, our R value is right here. It's not the R squared, it's just the R. So 0.7523. Okay, I'm going to put this away so that we can actually see this scatter plot. And if you want to zoom out, you might have to zoom out a little bit. But you can see your scatter plot. It makes sense that it would be about 0.7523. It's not perfect. This guy right here is kind of throwing a wrench in our plans. This guy here too, they're a little bit far out, but that's okay. All right, part A says interpret the slope. So So if we look at our slope, right, it's positive, meaning that this is going to be increasing. Okay, and then I always say make a fraction with your slope. You always have to have a numerator and denominator. Okay, so this is saying that the rating increases by 0.45 for every 1 gram of sugar in the pudding. So 0.45 over 1, that's where I'm getting those two numbers from. Okay, part B, does your R value suggest that the model is a good fit for the data? We would say yes. Okay, it's a moderate, strong fit. So it's not the greatest fit that we could get, but it's not terrible. Okay, using your model, what would the rating be for a pudding with 10 grams of sugar? So if we take this model that we have, our equation, we always call the equation a model. Okay, we want to know for 10 grams of sugar, which is an x value. So we're going to plug in 10 for x. Okay, I'm actually just going to use Desmos to help me out here. Okay, and we get negative 1.68. So that would be a terrible rating. But does it make sense? No, right? We really couldn't make a rating that's negative 1.68 because we can only go from 1 to 10 for our scale. So while the line of best fit can be good sometimes, it can also be a little unrealistic.